Effect of temperature on adsorption we have to discuss first. So first of all, what is x upon m here? X upon m is the extent of adsorption, where x is the mass of adsorbate and m is the mass of adsorbate. So higher the value of x upon m, greater will be the extent of adsorption. But in case of physical adsorption, if we observe, the x upon m value regularly decreases with increase in temperature. Because in case of physical adsorption, the attraction forces are poor van der Waals forces of attraction. Therefore, on increasing the temperature, these attraction forces builds up between the adsorbate and adsorbent. So the molecules of adsorbate start to separate and extent of adsorption decreases. But in case of chemical adsorption, the x upon m value with temperature continuously first increases then decreases. Reason behind it, during the chemical adsorption, the chemical bond formation occurs between adsorbate and adsorbent molecules. So these molecules requires the activation energy or threshold energy. Threshold energy, that is the minimum energy that must be possessed by the reactant molecule for a chemical change. So with increasing temperature, more and more molecules of adsorbate and adsorbent gain the threshold energy. That's why the rate of chemical reaction between them increases, means extent of adsorption increases. But at high temperature, the breaking of bonds between adsorbate and adsorbent molecules takes place, that causes the desorption, that is the separation of adsorbate molecules from adsorbent surface. Therefore, the extent of adsorption decreases continuously with high temperature. So this is about the effect of temperature on physical and chemical adsorption. Now we will discuss about the effect of pressure on adsorption. If we plot a graph between x upon m and pressure, then we are obtaining such type of curve. If we observe this curve, then there are three parts of this curve. One is this one, another up to this, and next is this one. So these are the three parts of this curve. First of all, if we observe this one, this is up to a very low pressure, and at low pressure, x upon m is directly proportional to the pressure because this is the straight line. Now, if we observe after this pressure, that is called the saturation pressure, this curve becomes parallel to the x-axis. It means there is no effect of pressure after this point on x upon m value, means at high pressure x upon m becomes independent of pressure. Means after saturation pressure, anyhow the pressure is applied, no change on extent of adsorption takes place. Next, if we go for intermediate pressure, at this it is neither directly proportional nor independent, so there is an intermediate state. So x upon m is proportional to p power 1 upon n, where n must be greater than 1. Or we can write x upon m is equal to k p power 1 upon n, and this is called Freundlich adsorption isotherm expression. Again I am repeating, Freundlich adsorption isotherm expression. If we take the logarithm of these both sides, then it is log x upon m is equal to log k plus 1 upon n log p. If we plot a graph between log x upon m and log p, then we obtain a straight line. And according to its straight line equation, y is equal to mx plus c, this intercept tells about the value of log k, while the slope will be equal to 1 upon n. So by this we are able to find out the value of n. And this is all about the effect of pressure on adsorption. For adsorption of solution, if we express the Freundlich adsorption expression, then instead of pressure, we use here concentration term, and it is log, this is x upon m is equal to k c power 1 upon n, where c is the concentration of solution.